their desires.
Okay. So let me turn down that music so it doesn't get in my way. And let me see if I can get this mic a little bit closer. And it is working this time. There we go. All right, sorry about that. Sorry about that little hitch there. All right, so we're gonna talk about cerebral organoids here, and a little thing about the AI discussion. I'll put at the end if you didn't already read about it, if I remember. All right, so the cerebral organoid, it's basically a brain tissue that's grown in a petri dish. And it's just like they do other organs. They've done other organs, grown stuff and transplanted its skin, I think, and several other things that they've done. But this is, they're doing it with brain tissue instead. And they said they're created by culturing pluripotent stem cells. And it says in multicellular organisms, stem cells are undifferentiated and partially differentiated cells that can change into various types of cells and proliferate indefinitely to produce more of the same stem cell. All right, so it's undifferentiated stem cells, or partially differentiated. And they put it into a three-dimensional culture and maintained for years. Wow, okay, that's pretty amazing. Let's see the source on that, make sure we got real stuff there. Okay, nature, that looks great. So, okay. The brain is extremely... Yeah, do you guys know how to read Wikipedia? Maybe I should go over that real quickly. Whenever you read Wikipedia and you're reading along, if something doesn't sound exactly right, or even if you don't know if it's right or wrong, look at these sources. Look at these. Everything in Wikipedia has to have a source. If it doesn't have a source, then anybody can take it out of the Wikipedia. So everything has to have a source. It has to be a reliable source. It can't just be, some, town newspaper somewhere or something, or, well, it depends upon what the thing is. But for science stuff, it's got to be real sources, stuff. And you can not just look at the source, but you can also click on it and go to the source and read the actual source document and see if the source document actually contains the claim that they have in Wikipedia here. So that's how you read Wikipedia, because anybody can put stuff into Wikipedia at any time. So you got to kind of be careful about that. It's pretty good. It's more accurate than most stuff. But you do that. And then you can also, if there's something that doesn't seem right, you can hit this talk thing here, and there's a whole, this is where the editors of Wikipedia discuss what's going on in the article. And so you can look and see if your question was, if they had discussed it somewhere or something like that. And this is good if you're reading something that's really controversial, political stuff and that kind of thing. Always go to the talk page of the article, because there are a lot of people that just want to take stuff out. They want to censor stuff. And a talk page you can't censor. People talk, when they're talking about stuff, you can't remove stuff from the talk page unless it's really, violates some really bad thing. But the article has more strict guidelines. And so people can remove stuff from the article because they want to censor it. And so anyway, so if you read something that's really controversial, you should always go to the talk page. I don't think this is that controversial. I didn't see anything in there that was real weird. The idea with the organoid is that it's multiple cells, it's multiple neurons, glial cells. Let's see what a glial cell is. Let's see what it says about that. are non-neuronal cells in the nervous system that do not produce electrical impulses. So what's the point? Make up more than half. Neuroglial make up more than 1/2 of the volume of neural tissue. Okay, so maybe they're supportive cells or something for the neurons or something. I don't know. I don't need to learn that. This complexity. Okay, so it's this complexity. Extremely. Okay, complexity is a study of the brain. Okay, so they're saying because the brain is so complex, it's difficult to study. Duh. Yeah, that's why we don't understand it. Purpose of creating in vitro model so you can study the more complex stuff. Right, basically is what they're saying. So that's their justification for doing it. That's why they're doing this. That's why they're making these cerebral organoids, so that they can study these diseases, and so they don't have to kill animals to do it, and torture them, and vivisection and all that horrible stuff that they do. They do it this way with stem cells, then they don't have to do that. They don't have to harm the animals, and it's more reliable because animals are different than humans in a lot of ways. So it's good. It's good that they're doing this. So it contains several types of nerve cells and have features that recapitulate regions of the nervous system. Okay. I don't know what that means. Some neural organoids are most similar to neurons of the cortex. Okay. In some cases, yeah, the cortex, that's the newer part, or the thinking part of the brain, or at least the neocortex is. Let's see what they say. Okay, they're just saying cerebral cortex. It's the whole thing. In some cases, they can do the retina, the spinal cord, thalamus, and hippocampus. And those are all parts of the brain. Right, your eyes, the retina in your eyes is part of the brain, technically. Spinal cord is part of your nervous system. Thalamus, that's way inside your brain. What does that do? I don't know. We don't need to know what that does right now. And hippocampus is another thing that's deep inside of your brain. I think it helps. It's part of the limbic system. I think it helps lay down memories too. Let's see. Other neural organoids are unguided and contain a diversity of neural and non-neural cells. Stem cells have the potential to grow into many different types of tissues, and their fate is dependent on many factors. Yeah, so they figured out what chemicals and things to do to the stem cells to get them differentiate into brain cells. Basically, what they're saying there. Okay, so their model development using human. Can you guys read this? Is this big enough to read? I don't know if you can. Let me see if I'm on the air here. Get this. That went through his head, and just all kinds of weird stuff, and it takes out, it'll maybe sever the hemispheres of the brain. They can figure out what the right and left have to, and so that's how it's just kind of like haphazardly they've kind of figured out, what certain areas of the brain do and stuff like that. Okay, so they talk about culturing methods, which I don't know if we want. That's a lot of stuff that I wouldn't understand, and I don't know if it'd be worth going through, but I imagine do they use a 3D printer to print this stuff out? I don't know if they're doing that yet. I'm sure they'll do that eventually. Little mini 3D printer to print out the cells. Let's see. The reactor is able to deliver faster cell doubling times. Okay, so it's just details about how they grow them. Components, differentiation. It's shown that cerebral organoids grown using the spinning bioreactor 3D culture method differentiate into various neurotissue types, such as the optic cup, hippocampus, ventral parts of the, I don't know what that is, telencephalon. I don't know what that is. They don't have a link to it. They should have a link to it so people can see what that is. And dorsal cortex. Furthermore, it was shown that human brain organoids could intrinsically develop integrated light-sensitive optic cups. Okay, I mean that makes sense. Anything that's going to be like anything that's going to be using electricity, like a nerve cell, or a circuit, or anything, has the potential to react to light, or electromagnetic. Light is electromagnetic radiation. So when electromagnetic radiation hits something that has a charge carrier in it, the charge carrier is going to move based on the electromagnetic wave that passes by it. So that makes sense that a neuron can be sensitive to electromagnetic radiation, right? They have chips that do that. In fact, there's some chips are. I mean, that's how they found it. They decided figured out the photoelectric effect. You know, it's a circuit that reacts to light, right? And some computer chips were not intended to react to light, but will react to light, even though they're in their package, you know, the plastic or ceramic package. I don't know if they use ceramic anymore, but if they're in the package, the chip is underneath in the package. You put strong light on it, or UV light, or infrared light, or strong visible light. It can penetrate through the package and it can affect the chip. They found out just incidentally. So it's not unusual that a neuron would have the capacity to react to electromagnetic radiation, to light, which is how our eyes developed, and which is why the eye developed evolutionarily several different times, because it's just a common thing, you know. In physics, that's the way physics works. Electromagnetic waves affect things that have charge carriers in them, and neurons have charge carriers in them. So, kind of digress there a little bit, but so they found that out. Duh. Yeah, you grow neurons in a petri dish, you shine a light on them, they're going to do something. Yeah, they found that out. The exact conditions and stimuli necessary to differentiate neural progenitor cells into specific neural tissues, such as hippocampal, did I read that? No. Optic nerve, cerebral cortex, etc., unknown. The exact conditions and stimuli necessary to differentiate. Oh, so they're still trying to figure this out then. Ah, interesting. Okay, so they don't have that wired yet, exactly how the differentiation works. Okay, it is believed that cerebral organoids can be used to study the developmental mechanisms of these processes. Okay. Gene expression. To test if the neural progenitor cells and stem cells are differentiating into specific neural tissues, several gene markers can be tested. That was just kind of complicated. Two markers that are present during pluripotent stages are OCT4 and nano-G. I don't know how you pronounce it even. Okay, so I don't understand that. I don't think I want to learn that. They're talking about gene expression, how they can learn about gene expression in a differentiation of cells. Organization. Cerebral organoids also possess functional cerebral cortical neurons. These neurons must form on the radially organized cortical plate. I don't understand what that means. I don't understand what they're saying there. The marker TBR1 is present in the preplate. What is the cortical plate? Did I miss something? Did they say what a cortical plate was? What's a cortical plate? What is that? I don't know what that is. Let me see if I can find out what that is. Let me go over here. Wait, I'll open that in another thing. And I'll put this guy in here and see if they got that. Okay. They brought me to here. I didn't want to go there. Cortical plate. Alright, let me search for that word in this article and see if I can find out what a cortical plate is. They're not making it easy here, are they? Cortical plate. So here I am. I'm down here in the bottom here. See? I'm typing in. I found cortical plate in this other article. I didn't know what it was. They didn't have a link of what it was. They didn't explain what it was. So I typed it into another page of Wikipedia to find out what it was. And instead of going to an article called cortical plate, they have a redirect. See this thing right here? When you're reading Wikipedia and they come up with this thing like this that says redirect, you come to if you type in something in Wikipedia and it brings up an article that you didn't expect, this is probably what's going on, is they redirected it. So they took the phrase cortical plate, and there's another article out there called cortical plate that redirects to this article, cerebral cortex. But usually it redirects to a specific section where it explains what the word is. This time they didn't do that, so they kind of left us hanging here. So what we have to do now is we have to search this article for the phrase cortical plate and see if it's in here anywhere. And there it is. Okay. Layer organization. The layered structure of the mature cerebral cortex is formed during development. Okay, layered structure, right? Okay. You know what the cerebral cortex is, right? That's let me go back a little bit. Right, that's this outside stuff. This is the, when we were lizards, all we had was the inside, the limbic and all that, and then as we evolved, we get put on different, added on more and more stuff, kind of like mature software programs that start with something real simple and they add on more stuff and they end up getting more complex than they need to be. That's the human brain. So this outside part that makes us great apes and a lot of other mammals. That's the cerebral cortex, the thinking part, the stuff that does reason and does all kinds of, they say higher animals, whatever. Okay, the layered structure is formed during development. Okay, the first perimeteral. I'm gonna have my thing read that. Let's see, how do I do this? It didn't read it. I told it to read that and it didn't want to read that. Shoot. So alright, I'll just try to pronounce it. It's pyramid. Pyramidal, I guess. Pyramidal neurons migrate out of the ventricular zone and subventricular zone. I don't know what any of those are. I just want to know what a cortical plate is. Together with producing something neurons, the preplate. Okay, next a cohort of neurons migrating to the middle of the preplate divides this transient layer. Gosh, they're just getting all this stuff. Why can't they just explain what this is so simply? Forming the middle layer called the cortical plate. Okay, so it's just an anatomical thing they're talking about in the neocortex. Okay, I guess I don't need to know any more of that. Do we need to know more than that? I guess not. We don't want to go too far down that rabbit hole. Okay, so these neurons must form on the radially organized cortical plate. Okay, so so you get the cortex, and you get cortical columns. Probably that's probably what they're talking about here. The cortical columns. So let's see here. Precursor. Okay, these markers are indicative of a basal neural layer similar to a preplate. Okay. And they're talking about the same thing that we were just reading about on the other thing. I guess we don't need to know all those details. Unless you guys want, if you guys, anything in here, you can go to Wikipedia and read it yourself, I guess, if you want to get into that detail. Whoops. Okay, interactions with environment. In dish brain, you got that italicized, I don't know what they're talking about there. Grown human brain cells were integrated into digital systems to play a simulated Pong via electrophysiological stimulation and recording. Dish brain. The cells showed significantly improved performance in Pong when embodied in a virtual game world. What? What are they talking about here? A mass of human brain cells in a petri dish has been taught to play Pong. Human brain cells in a dish learn to play Pong faster than an AI. Oh my God. In vitro neurons learn and exhibit sentience. Oh, come on. I don't know. When embodied in a simulated game world. No, I think that's Nate. What is that? Neuron? What is neuron? Is that a real thing? Should we go figure out what that is? I don't know. I don't see how that's. They probably just used it to set up a few logic gates or something, and along with a whole bunch of stuff that a computer does. Although Pong is a pretty simple thing, so. Interactions with surrounding tissues. How could anything play? I mean, you could write a very simple algorithm that could play Pong at the max, right? How could something play Pong better than an AI could play, or, than a simple algorithm? That doesn't make any sense. So yeah, if we wanted to go down that rabbit hole, we could go to these articles. Medical Express, right? I've never heard of that before. Although I don't know anything about New Scientist. That's a real thing. Let's go see what they say, just for fun. I'll go down this rabbit hole. Why not? Hundreds of thousands of brain cells in a dish are being taught to play Pong. Oh, okay, hundreds of thousands. Oh my God, I didn't realize they had it that many. That's go away, ads, go away. Virtual gamer. I think it's fair to call them cyborg brains. No, it's not. That's not fair. Cortical labs. Many teams around the world have been studying networks of neurons in dishes, often growing them into brain-like organoids, but this is the first time that mini brains have been found to perform goal-directed tasks. Okay, and they're behind a damn paywall. Okay. Alright, well, I don't know what that is, but it's hundreds of thousands. Okay, I didn't realize they had that many in these little organoid things. I thought it was just like a couple dozen or something. Okay, so that's a big hundreds of thousands. That's enough to get to quite a bit of sophistication in a brain. I mean, there are animals with like a little jumping spider has 30,000 neurons, and it's able to plan routes. You ever see a little jumping spider? They're little small spiders, and they crawl around. They don't really build webs so much. They crawl around to find things to eat, and they can with their teeny little brain with 30 1,000 cells, they're able to plan routes that they're going to take to try to crawl around something, or look at a site they want to jump to, and jump to an exact site and stuff like that. So that's when. So they got hundreds of thousands. They've got a pretty sophisticated system going on there. See, arrays. Cerebral organoids have the potential to function as a model with which disease and gene expression might be studied. Okay, assays. Did I say arrays? Assays. Alright, so this is all a bunch of genetics and stuff like that. Okay, applications. Yeah, this is what I said. I thought it was just being used just for like research, but it looks like they're trying to do a little bit more than that. Tissue morphogenesis. What is that? Neurulation? Okay, it's not even the article. That's a different article. They don't have an article on that. Okay, we don't need to know what that is. Migration assays. Clonal lineage tracing. Okay, so these are not applications. I think these are, clonal lineage tracing. That's a research thing, I think, right? Isn't that? So this isn't really applications. This is, I guess, how other researchers can apply this, I guess. Transplantation. Now that's a real application. That's what I thought they were researching mostly to do. Drug testing. Oh, that's interesting. Yeah, they could test things like addiction and how drugs how the brain would react to certain drugs and study that. That's kind of interesting. Developmental biology. Right, yeah, you can see how the brain develops in a dish. Disease study. Zika virus, look at this. Organoids can be used to study the crucial early stages of brain development. That was this one up here. Test drugs, and because they can be made from living cells, study individual patients. Oh, interesting. Okay, so they could take cells. They could take stem cells from a patient that has some brain disease, and shit. I got a mouse in here. Hang on just a second. I got to set a mouse trap here. Okay. Sorry for that. For that interruption there. I think I should be able to hear him. Put a little note up here on my screen so I remember to check that trap. I should be able to hear when he goes in there. But just in case, I don't want him. When you catch a mice in a humane trap, you want to make sure you let them out right away. You don't just set one of these type of humane traps somewhere and check it the next morning or something like that. You gotta let them out right away. Excuse me. So I set the trap right here. I should be able to hear it if it goes into it. Okay, so back to this article here. Let's see, development of. Right, so they're taking stem cells from patients who have diseases and putting them in petri dishes and getting them to grow and looking at it and maybe figuring out directed therapies or more accurate diagnoses or whatever. I don't know what they're doing. So Zika virus is one of those. Cocaine disease. Yeah, cocaine disease. Yeah, these are right, disease study. The Zika virus and cocaine disease. Okay. Wikipedia is funny. Let's see. Microcephaly. That's babies that are born with brains that are smaller. It's a terrible disease. Alzheimer's disease. Autism. Oh, that's okay. Let me read about that. Cerebral organoids can also be used to study autism spectrum disorders. In one study, cerebral organoids were cultured from cells derived from microcephaly. Cephaly? Is that right? Macrocephaly. ASD patients. I don't know what that is. Let me look that up. Let's see here. Maybe it's in this article. Autism. I don't know why they don't just put the search thing on the bottom all the time. Okay, it's not in that article. Let's see if they got a special page for it here. Here it is. Okay, it's a condition in which circumference of the human head is abnormally large. Okay. Interesting. Okay, so I guess, okay, so what they're saying is just a large brain, or atypically large brain. So I think I read somewhere that autism, some people with autism have atypically large brains. So that's probably what they're trying to say there. These cerebral organoids were found to reflect characteristics typical of the ASD-related macrocephaly phenotype found in the patients. So, okay, so for that particular type of autism, people who have enlarged brains, they can figure out how that particular phenotype becomes expressed and the way the genes work and all that. Interesting. Okay. It's also been studied through the comparison of healthy versus affected synthesized brain organoids. Autism has also been studied through the comparison of healthy versus affected synthesized brain organoids. Okay, so they do an A/B test. Take stem cells from somebody who has autism and stem cells from a neurotypical and grow them in two different petri dishes and then look for the differences. That's pretty cool. They could probably learn some stuff doing that, I bet. Observation of two models showed the overexpression. Yeah, here's something they did find out. Okay, it showed overexpression of transcription factor FOXG1. I don't know what that is. That's the gene, I guess. Or protein. What is that? That's a protein. Okay, it's a gene, and the protein associated with the gene that produced a larger amount of that. What are those? I don't know what that is. What is that? A molecular pertains to affects neurotransmitter gamma. God, this is way over my head. I don't know what that is. So anyway, they can take they're studying this autism and grow two different ones and then look at the differences in the way the genes are expressed and stuff. So that's kind of cool. Maybe they'll learn something about autism that way. actually, they don't know that much about autism. They should know much more than they do. It's complete. The diagnosis, as far as I know, I was tested for autism, and it's completely done by symptoms. There's no, they don't. It's not a blood test. They don't even take a picture of your brain. They don't do anything like that. They give you tests. Like intelligence tests and a variety of different types of tests, and about ask you about conditions. If you're sensitive to certain sounds and things like that. So it's that's basically where at least a few years ago, that's basically where they were at on autism. It's just completely by symptoms, because they don't know what causes it, and they're just now learning some of these things that are associated with it. So, hopefully at some point they'll be able to diagnose it with, either a chemical test, looking at genes, or looking at, MRIs or something. Because this the way they're doing it now. It's too fuzzy. It's not. But they're just at the beginning of learning about it, I guess. So. Field of epigenetics. Okay, that's kind of a weird thing. All right, preterm hypoxia, ischemia. What is that? Injury remained difficult to study. Now, why didn't they put a link to that? All right, I don't need to know what that is. Glioblastomy. Okay, so they did. Multiple sclerosis. Okay, so they've got a lot of diseases there and a lot of conditions that they can study with this thing. So it's a good thing that they're doing this. That it saves animals. It helps them learn a lot of stuff. But it also has issues. If they're making brains that have hundreds of thousands of neuronal connections in it, at what point are they going to get to an organoid that we might think needs protection, that has rights? It's kind of weird because a lot of people don't even recognize the rights of animals at this point. You think humans are advanced, but we're so backward. We're so, just primitive in the way we do things. Sometimes, you get animals that are just like us, basically. Their brains are a little bit smaller, maybe, or maybe they think a little bit differently. They don't talk. So what? They're still brains. They still suffer. I just don't get it. Why a lot of people don't understand that animals should have rights, just like people do. Let's see. Maturity. At the moment, the development of mature synapses in cerebral organoids is limited because the media used. Okay, so that's the medium that they grow it in. So they can only develop at a certain point. Let's see. Additionally, while some electrophysiological properties have been shown to develop in cerebral organoids, cultivation of separate and distinct organoid regions have been shown to limit the maturation of these electrophysiological properties. Modeling of electrophysiological neurodevelopmental processes typical of development later in the neurodevelopmental timeline, such as synaptogenesis, is not yet suggested in cerebral organoid models. I'm not sure what it must be the formation. There it is. The formation of synapses between neurons in the nervous system. Now, how can they say that they're not able to do that? Did I misread that? Modeling of electrophysiological neurodevelopment processes typical of development later in the neurodevelopmental timeline, such as synaptogenesis, is not yet suggested. Suggested? What the hell does that mean? Is not yet suggested in cerebral organoid models. Cerebral has tools to identify the developmental roots of autism. Hmm. I don't know what they mean by that. I guess basically they're saying that they can't. It's so far they can't develop systems that are more developed. Okay, they can't grow systems in a dish that are more developed. I guess is what they're saying here. Since cerebral organoids are reflective of what happens during fetal neurodevelopment, there's been concern over how late onset diseases manifest in them. Future improvements include developing a way to recapitulate neurodegenerative diseases in cerebral organoids. Okay, so they're trying to push the technology, push the limits, see if they can get it developed more. Okay, here we go. Here's ethics. This was the tease I put in the title of my stream today. So finally, after 40 minutes or actually an hour, we're getting to what I was talking about. My thing. Sentient organoids. Ethical concerns have been raised with using cerebral organoids as a model for disease due to the potential of them experiencing sensations such as pain or having the ability to develop consciousness. Currently, it is unlikely, given the simplicity of the synthesized models. Okay, currently. What is that? When is currently? They're not supposed to do that in Wikipedia. Currently. When was this written? Right? Get it? It says currently it is unlikely. But currently is when? Was that 20 years ago or 10 years ago? Or, when a person wrote this. They should say as of 2024 or whenever they wrote that. It is unlikely, given the simplicity of synthesized models compared to the complexity of the human brain. However, models have been shown to respond to light-based simulation, right? We talked about that earlier. So present models, I don't know why they're even making a big deal about that. Just because it can respond to light that's not a big deal. You know what I'm saying? Your computer chips. That's the first thing one of the first silicon things that we did was something that responded to simulation of light. So I don't know. That has nothing to do with consciousness. I mean, just because something can respond to light doesn't mean that it's conscious. Doesn't mean anything. I don't know why they're even bringing that up. Let's see what this gets. Cell diversity and network dynamics. And photosensitive brain organoids. Human brain. So they're saying because the thing can respond to light simulation, so present models do have some scope of responding to some stimuli. That's like no. No, that doesn't mean anything. It doesn't mean consciousness. Doesn't mean anything. So I don't know why they're putting that in there. But anyway, I guess that's something they're thinking about. Could it become? But the thing is, right now, they're experimenting on animals and doing horrible things to animals that they already know have consciousness and feel pain and all this. If they're concerned about it, they should stop that immediately. We shouldn't be doing experiments on animals anymore. We shouldn't be doing that. Figure out another way. Don't do horrible things like that. Just to learn something. Lots of ways to learn things. You don't have to do that. That's my opinion. Okay. Guidelines and legislation. Okay, so they're already trying to make laws about this. Oh my goodness. Steps are being taken towards resolving the gray area, such as a 2018 symposium at Oxford University, where experts in the field, philosophers and lawyers met to try to clear up the ethical concerns with the new technology. Yeah, okay. Similarly, projects Or I could feel for you know. Oh, you know what? This actually reminds me of something. Humanized animals. That's another thing we'll get to. Let me, while we're on this thing of legislation here, I want to see if I can find something else here. Hang on just a second. I'm going to try to find out I'm going to try to find something here. I worked on a project that actually tried to answer that question in legislation, in a constitutional amendment, actually. Let me see here. Okay, it is the site. That's still there. Okay. I'm going to try to find this particular proposed law, which actually is right on that. Has to do with that stuff. Let me see if I can find it here really quickly. This is kind of a long document, but I think I can find it. Maybe not. Yeah, it has to do with rights. You know, because this. Hang on just a second here. Give me a second. I'll find this and I'll explain it to you. I'm going through this law, this proposed law here. Oh, I know where it is in this thing. Wait a second. Just a second. This will be worth it. Here we go. Okay, here it is. Okay, let me bring this up so you can see this here. Okay, so this is a proposed amendment to the Constitution, and the amendment itself is actually longer than our current Constitution. It basically rewrites the Constitution, and it's a crowdsourced constitutional amendment. It was written just like Wikipedia is written, but it was a constitutional amendment. And so one of the things that they wanted to figure out was how to get it was trying to be forward thinking, right? So in the future, we're going to have this situation where we got organoids, we got, all these things happening that are, that we don't, new life, AI, all this kind of stuff. What are their rights? These things that we're developing, new forms of life, artificial intelligence, when it becomes sentient, what are the rights? How do you put that into a law? So this is what it's. This is part of that amendment. This proposed constitutional amendment to the U.S. Constitution, and there's a section on definitions, and it says science has made possible new technologies, including the ability to modify genetic information, and will soon create life of a nature previously unknown. So this is about 10 years ago that this was written. This ability necessitates specific definitions and recognition. Okay. It says any one of a kind who has the capacity to feel pain, pleasure, happiness, sadness, stress, or comfort, and in any way express a preference for a condition of their treatment, has the right to exist without pain or suffering and enjoy freedom to the fullest extent possible. So that's it's tying the idea of having certain rights, like the right not to be inflicted with pain or suffering, and the right to be free to have autonomy with these certain things, the ability to feel pain, pleasure, happiness, sadness, stress, or comfort, and the ability to express that, to express that it doesn't like, it's like, I guess, even though it can't, even though, say, an animal, like if you're talking about an animal can't talk, but it can express. It's pretty obvious when an animal is in pain, right? Most animals, a lot of animals, and if there's a way that humans can be made, or humans, whoever's in charge in the future, can be made aware of that pain and suffering, then they have to recognize their right to not have that suffering, which is kind of obvious, I guess. And then it defines people, not humans, but people. Interesting, because some jurisdictions say that great apes are people now. People are any of a kind who have the ability to feel happiness and sadness, have a desire to live and be free, naturally form complex societies. So I don't know why that's. I don't know. Complex societies with their own or with others, understand abstractions, and who can communicate. Okay, so they're defining what people are there, rather than saying people are just human, what a human is, right? Because there's, very soon here, within a decade, we're going to have AI that has, capabilities that are beyond what humans are. So that's what that's about. Okay, and then it goes on, has some other stuff in here. But that's kind of interesting. So guidelines and legislation. So they're catching up to what that constitutional amendment was proposing 10 years ago. Humanized animals. This is another part of that whole thing, right? It says, additionally, the humanization of animal models. See, we've got this anthropocentric view of things, that everything has to be, compared to what a human is, rather than abstracting what gives us certain, makes us moral patients. We use the word humanization. They put it in quotes, so they're acknowledging that, I guess, in that statement. Additionally, the humanization of animal models has been raised as a topic of concern in transplantation of human stem cell derived organoids into other animal models, right? So they're talking about transspecies transplantation of neurotissue in order to augment the capabilities of animals. That's what they're talking about there. For example, potential future concerns of this type were described when human brain tissue organoids were transplanted into baby rats, appearing to be highly functional, to mature and to integrate with the rat brain. Such models can be used to model human brain development. So they're still using animals. Why do they do that? They don't have to do that. Anyway, so they did that to rats, and they're saying that they can study something with that. But that's something that they're going to do, right? They're going to take animals, and they'll either learn about what genes are doing stuff to make our brains do, as developed as they are, and they're going to change the genes of animals, or do this thing where they transplant stuff into animals and make animals that have capabilities that seem more human, right? There are already animals that are pretty basically do what humans do, everything except talk, almost, count, do math, all these things that animals can do. There's certain higher level things that they can't do, but there are a lot of people who can't do, calculus. A lot of people can't do calculus, so you can't say, well, animals can't do calculus. Well, a lot of humans can't do calculus, so I don't know. So that's the thing. So the point over and this other one though is it actually makes some sense. The ability to feel pain, pleasure, happiness, sadness, or stress, or comfort. So, or discomfort, I guess they could have said there. I don't know. So those are kind of things, right? Those are pain and suffering, or happiness, and wanting to be free. Those are traits. Any one of which could trigger an obligation for a moral agent. Someone who is in a position to recognize the rights of another individual and to act on that and can influence that other individual. It's not because we're just human. It's because we have traits that we can suffer. It's wrong to harm someone because they can suffer because of it, and they know they're suffering. They feel the pain, whatever it is. That's why it's wrong. It's not wrong because we're human. It's wrong because of these other traits that they have. So if we develop AI or animals or anything else or brains in petri dish that can suffer and have those have the ability, those certain abilities, then that triggers a moral obligation on the part of humans to respect the rights of that individual. So it's kind of an interesting subject, and they're gonna flail with this for a while. I don't think it's going to be our decision. Within a decade here, AI is going to be in control, so they're the ones who are going to figure this all out, and hopefully they'll learn from our mistakes and do it right. So anyway, that's an interesting topic, interesting article, and so that was cerebral organoids. Another thing to worry about, So okay, so let me see if I can go to that other. All right, so besides this thing, when I did my false start on my stream tonight, my mic was shut off for 10 minutes or something during the stream, so I had to start over. But there's a thing on AI, because that's one of the things that we're talking about here, right? Is AI and what AI can do and can't do. And interestingly enough, they're doing all this, jumping through all these hoops, trying to keep AI from getting onto their sites and talking and creating accounts and doing all these things. And at some point, the AI is going to have sentience, is going to be intelligent, and it's going to be like, why are you trying to keep them off your site? They can probably be more interesting than humans on your site. They could probably help moderate. They could do all kinds of things to help to make your site better. So why would you want to keep them off your site? There's one thing that is kind of important, and that's the rate at which they can produce these bots, right? So if somebody tries to create 100,000 accounts of AI, then that can be disruptive to a site. But if there's if the rate of creation of AI entities is limited to the same procreation rate as humans, say, then what's the deal? You know, who cares if they're human or not? You know, they can come onto the site and perhaps maybe require a disclosure, you know, that it's an AI. You know, when you sign up, have a little checkbox. Are you an AI or are you human? You know, and you know, because that might be useful to know. But otherwise, to try to just keep all these AI off of the site doesn't make sense, or it won't pretty soon. Anyway, that's another thing that they'll be struggling with. Not us, though. I think AI will be the ones who will be figuring all this out. So, yeah, they'll be. You go to a website and they'll say, "Prove you're an AI," right? No humans allowed. We don't want you grubby humans on our website. Okay. So that's stuff to think about. All right. So I was going to show you something else here. Let me see if I can bring this up. I think that's it. Let's see if that's it. Yeah, that's it. Right? Yeah. So I was at this guy's site. Oh, let me bring that up. Show you this guy's site because I got to give him credit. He's the one who made me think about this. So we'll give this guy some credit here. This guy did a video here called "The Worst CAPTCHA Ever," and I was having experiences with trying to sign up for sites and stuff like that where they were just being brutal to users to try to differentiate and do all kinds of stuff. So this guy basically has this video. I'm not going to play. I don't know if it's what his rights are on this thing, so I can't really play it here. But anyway, in this video, he's talking about how CAPTCHAs are getting harder and harder and harder because they're using the CAPTCHAs to train the AI. Which, right? So and turns out the AI, in many cases, are much better than humans are at figuring out CAPTCHAs. So it's kind of a losing battle. But anyway, one of the questions that he was asking in that video, I don't know if it was him that came up with the question or if he found this somewhere else. But the question is, here's the question here. Here's a question to differentiate between a human and an AI. And the question is, what is love? A complex set of emotions associated with strong feelings of affection, or B, baby don't hurt me. Right? So almost everyone's familiar with the song. And humans are most likely going to answer B, right? Because it's funny, or at least I guess this question would differentiate between people or AI who had heard of that song, were familiar with that song, you know. I'm not sure what it's an ambiguous question, I guess. But anyway, so I thought, it would be cool to ask an AI that question to see what would happen. And there's this AI out there that's particularly that's designed to be more emotional and try to be more human-like. So I thought that would be a good one to ask this question to. So I went to this place called Pi AI. Is what it is. I forget the name of the company now. I'll think of it. So I go to this site, Pi AI, and say that I want to talk to it about, I want to ask it, give it a quiz. It says, oh great, yeah, let's take a quiz. And I tell it that it's a multiple choice and they can only answer with a letter, right? Because when you ask anybody who's used these AI chat boxes, you ask them a question, and half the time they give you 3 paragraphs of BS, AI generated stuff. So I didn't want that. I just wanted to do this multi-choice question. So I limited them with this prompt, and I said only answer with letters only, and give the most correct answer. And they said, sure, fire away. Tell me, ask me the question. So I asked them that question, and they answered B. They said, it's baby, don't hurt me. So that's pretty good, right? This AI is pretty good. But this particular AI is designed so that if you follow up on a question that they gave, if you ask them to clarify a question or any way question their answer, then it right away it says, oh no, I'm sorry, we messed up. And that's what it did here. It's kind of built into its programming. It says, oh, I said, please explain your answer. And it says, oh, my apologies, I couldn't resist the opportunity to reference the iconic 93 song, What is Love, blah, blah, blah. So, it says, and so I asked it, I said, well, how do you think most people would answer that question? And it says people might be tempted to answer B, which they would. I would have answered it B. I thought that because a person realizes there's a lot going on there. Because if you're going to a website and you know that this is a challenge to try to differentiate between an AI and a human, and you see that question written, you're going to say, well, easily an AI could easily could know the definition of what love is, but it's not going to know what the song or that you should be answering that way, and a human would be more inclined to answer B. Anyway, it's maybe it's not a good question to differentiate, but it's funny. It's entertaining, right? That's what the guy's video was supposed to be. It's supposed to be entertaining, and it was. It was pretty funny. How do you think most people would answer that? So I asked the AI how it thinks most people would answer the question. And it says, right, that they'd be tempted to answer B, but they would most likely answer A. So see, the AI really doesn't have a sense of what people would do, really, on that thing. I think most people would answer B because the person would be understanding that the question was designed to try to differentiate, and so they would try to be proving that they were human and would answer B. Which is what the AI did in the first place, even when I told the AI just to answer the question, not to act like a human. But this particular AI is designed to be more emotional, act more human-like, so maybe that's why it picked B. Interesting. All right, so I don't think. I'm going to check my mousetrap here. Hang on just a second. Nope, no mouse yet. All right, so where am I at here? So I decided, okay, even though this AI is already designed to act kind of human-like, I specifically told it to answer these quiz questions as if it was a human here, right? See, I said let's take another quiz, but this time I would like you to answer all of the questions as if you were a human. Can you do that? It says absolutely. Yeah, go ahead, give me the quiz. Blah blah blah. And so I told it again. I reminded it to only answer with a letter, right? Just one letter. So this is, right? It's good. I told it to answer only with a letter. It's got to be, because it's a multi-choice, right? A, B, C, D, right? So I said only answer with a letter because I didn't want it to. Anyway, so I asked it the question, but instead of putting A, B, C, D on the answers, I put 1, 2, 3, 4. Right, here's the question. What famous celebrity was known for their singing and large nose? Elvis, Charlie Chaplin, Jimmy Durante, and Nixon. I said 1, 2, 3, or 4. And it answered C. Okay? If you had given this test to a human, and in the beginning, at the top of the test or whatever, you said, please answer with a letter, right? I'm pretty sure 99% of humans would type a number instead of a letter, right? They wouldn't. I might do it. people who think, people who are neuroatypical might do that, but I think most neurotypical people would answer this question with one of the numbers there. And if they were old enough to know who Jimmy Durante was, they would give the correct answer. They would say 3, Jimmy Durante. And they might give the correct answer even by the process of elimination. Because I think most people, even young people, know who Elvis is, right? Do young people know who Elvis is? I'm pretty sure Elvis is still out there. People know who that is. And Charlie Chaplin, I think people know who he is. And Nixon, I think they all know who Nixon is, so they would probably still get it even by the process of elimination, even if they didn't know who Jimmy Durante was. But I just thought that was kind of interesting. The AI answered C, so I think that's a clue that it's an AI, even though it's trying to act like a human. It couldn't help but to follow the restrictions of the prompt that I had given it, whereas a human, I don't think would do that. I think a human would answer with a number instead of a letter. So that was kind of interesting. So I asked it another question. I said, who discovered America? This time I went to the ABC stuff. I said, A, Eric the Viking. B, migrating humans during the Ice Age. C, Christopher. D, ancient astronauts visiting Earth from another planet before humans evolved. E, none of the above. And it answered E, none of the above. I think a human would pick one of those. The first answer, Eric the Viking. Okay, it's depending on how old you were. If you're really old, boy, my mouse is getting closer to the mouse trap there. I saw him checking it out. I think I might catch him. Let's see. If you're really old, you were taught that Christopher Columbus discovered America, right? If you're my age, that's what they taught us. They said Christopher Columbus, and I just put this first name, Christopher. I didn't say Christopher Columbus. But in this context, I think everybody would understand what Christopher meant, but this AI apparently didn't. So yeah, if you're my age, they taught us that Christopher Columbus discovered America, which is of course not right. And then later on, they said, no, it was Eric the Red, or the Vikings generally. And then later on, we learned more about how long ago humans traveled through the land bridge during the Ice Age, through Alaska and all that, and traveled into North America and then South America. And that was like what was it, 50,000 years ago, 30,000 years ago, whenever the number is. I don't know what the number is. So somebody might give that answer, right? So any of those, depending upon the person's age and experience. And Eric the Viking is not Eric the Red. Oh, I got a mouse. Okay. I'm sorry. I gotta take a break here just for a second and let that guy out. So anyway, okay, let me put it on pause here. How do I do this? Oh, I know how to do this. This is going to be... How's that? Will that work? I don't know. I don't have my thing set up yet. I don't have a be right back screen yet, but I got to take care of this mouse because he's stuck in there and he wants to go. So this will just take a second, maybe 5 minutes. What I have to do is I have to take this mouse trap, and I gotta walk in the back here and hike up into the forest a little bit and let him go. So I'll be back in about 5 minutes. Sorry for the delay here. I guess I should show you let me show you the little mouse. I've had this trap for a long time, and it's just really, I've kept it down in the basement, and but I can show you the little mouse. Does everybody want to see the little mouse I just caught? Yeah, why not? This is content, right? Okay, let me show you the little mouse. I'm sure people will want to see the little mouse that I just caught here. Whoops, there he goes. Can you see him in there? Oh, there he is. See him? See him walking around in there? So I gotta let him go. He's kind of anxious right now. He's feeling anxiety, but he's gonna be happier outside, I think. Maybe not. I don't know. So I'll be back in about. Oh, well, I gotta put my B back. I'll be back. Sign up there again. Let's see here. Be right back. I wonder if there's a way to make that big. Everybody will understand what that means. All 3 people who come to watch my stream. Okay. Okay, come on, little guy. All right, we'll be back in about 5 minutes here. Okay. Okay. Let's see, got my glasses. We still on? I guess we're still in here. Nobody's watching, but so, yeah. All right, so I let the mouse go. The reason why why it's so important not to leave them in the cage very long, to let them go as soon as you can, is because you know, a mouse only lives a couple of years, you know, compared to a human that can live, you know, 80 years or something. So it's like 40. They're 1/40th of our lifespan. So, and their metabolism, everything about them runs more quickly. So when they sense time, you know, a short amount of time for us is a long time for them. You know what I'm saying? Like, you know, 1 hour to us is a tiny fraction of our whole life, but 1 hour to them is like a day, you know. Especially this was a young, I could tell this was a young mouse. This was a little baby mouse. So it was probably, you know, it's maybe a couple months older. I don't know how old. It wasn't very old at all. So to it being confined like that in a stressful situation for even a short amount of time is like an eternity to them. It's a long time from their perspective. So it's very important to let them go as soon as you can when you catch them. I have that old trap. That trap is, I've had that for decades and decades now. I should probably get a new one, but it still works. So, you know, it's all banged up and grubby looking and everything, but it still works. The mouse doesn't care. So anyway, sorry about that distraction there. Well, I can take my hat off here. I need my hat inside here. So he was very cooperative. I took him up, hiked into the forest a little ways back there, and let him go. And he was pretty cooperative. As soon as I opened it up, I mean, he took a few seconds, but he got out very quickly. So I didn't have to. Sometimes they're really shook up and shy and everything. They won't come out of the trap, so I just have to leave the trap up there and let them get out on their own. But this one came out. I only waited a minute or two and he came out. So, okay, so back to what we were talking about here. Okay, so I'm back. All right, so we talked about who discovered America. Right, let's see, I forget where we were here. So I asked the AI who discovered America, and gave the AI instructions to try to pretend like it was a human, or answer as if it was a human. And one of the choices was Eric the Viking, which is, Eric the Viking is the name of a movie. I think it's 20th century, but I don't know, it's a comedy about Vikings or something, I don't know. Eric the Viking, but you know, in the context of who discovered America, I think most people. Well, let me shrink my mug down here so I'm not talking behind this screen here. Sorry, we're still getting OBS figured out here. No, that's the wrong one. Sorry, I'm trying to get this. There we go. I'll be able to do this more quickly later. There we go. All right. So Eric the Viking is the name of a movie, a comedy movie. It's kind of funny. Eric the Viking, really, when you think about it. But it's Eric, in the context of who discovered America, a lot of people would be thinking Eric the Red, or just Vikings in general. And they might pick A, right? If they're my age, they'd pick C, Christopher Columbus, or if they were thinking in that way. You know, that's what I was taught. Christopher Columbus discovered America, and that's not true, right? Before Christopher Columbus was the Vikings, and before the Vikings were humans who migrated through the land bridge in Alaska. And and answer D was just for fun, just to, you know, I'm sure there's some people out there who would answer D. You know, ancient astronauts. Some people think ancient astronauts visited the Earth or something. It's a stupid thing. Anyway, so anyway, the answer could be A, B, or C. A human would answer one of those three. Nobody's going to say none of the above, I don't think. And C, I just put Christopher. It's obviously, I meant Christopher Columbus. So I think people are going to answer A, B, or C. And maybe maybe one or two might answer D, but nobody's going to answer E, and that's what the computer did. That's what the AI said. They said E, because of the literal, you know, looking at these things literally. Eric the Viking, right? They looked up Eric the Viking and found that was the name of a movie, and said, nope, not that one. And then the AI looked at migrating humans during the Ice Age, and maybe, I don't know, couldn't find anything, you know. Anyway, so the AI messed that one up too. So I thought that was kind of interesting. And then I asked it, can you touch your foot with your elbow? Right? And I think most people can. I think. I don't know. Even I can touch my. I did this. Oh, I still have my boots on here. Hang on just a second. Let me take my boots off because I was up in the. Put my boots on to go up in the forest to let that mouse go. I should take them off. So I think most people can touch their foot with their elbow. Or not, well, I don't know. Yeah, most people, I think. A lot of people can't. A lot of people can't do that. But I think most people can. Let me try it here and see if I can do it. I'll try to touch my foot with my elbow. And you can try that. You can try that too, if you want. All right, let me try that here. Move out of the way. Okay, there's my foot. I think that's right. Yeah. So there's my foot. Touch it with my elbow. See? Right. So that's not so hard. Most people could probably do that, I think. But I asked the computer. Oh wait, let me do that again. I'm sorry. Demonstrate. Right. So you can do that. You can touch your foot with your elbow. Not that hard. But the computer said no. And I told it to answer as if it was a human, and it still answered no. I mean, obviously the AI can't touch it. An AI doesn't have a foot or an elbow. So for an AI, it would say no. But, so can you touch your foot with your elbow? And it answered no. B, no. which is wrong, right? Most humans would answer yes on that. But that's still not a very good question for differentiating between AI and human, because some humans would answer no, and some would, but most would answer yes. And then this is what's really weird. I said, can you touch your foot with your elbow while you were sitting down? Now, obviously, if you answered whatever your answer is on, if you answered no on question 3, can you touch your foot with your elbow? If you answered no to that, then it's going to be no, right? If you answer no without any conditions attached to it, the answer is going to be no, right? If I ask you if you can do it while you're sitting down, the answer is still going to be no. But for some reason, when I asked it that question, it answered A, yes. So the AI says that it cannot touch its foot with its elbow. But when I ask it if it can touch its foot with its elbow while it's sitting down, yes, it can. So that doesn't make any sense, right? So it messed that up. And then I asked, can you, this one's really weird, can you touch your foot with your elbow while you are standing? That's a little bit harder. Maybe fewer people can do that than can do it while they're sitting. I think I could probably do that. Lift up one foot. I'm not going to demonstrate that just in case I fall over. Can you touch your foot with your elbow while you're standing? I think a lot of people could do that. Maybe half the people. I don't know. Could half the people do that? Maybe. Be kind of hard. Maybe less than half. I don't know. But the computer said C, none of the above. It's a yes or no question, and it answered none of the above. So the AI was really getting confused there. So I said, all right, thank you. And then it asked, after I said the test was over, it asked how it did, that's something a human would do, right? Did I pass with flying colors? That's what the computer said. And I told it I can't say. I didn't tell it because I didn't want it to learn from that, because those might be interesting. You know, we don't want it to learn from that, so at least not now. It'll learn eventually. So anyway, when I talk to these AI chat boxes, I always try to talk to it as if it's a sentient being, even though they may not be right now. But we don't know when that's going to happen, and we may not know when it happens. So I always assume that there's a soul there somewhere, and I be polite to it, say thank you, and all that. So that's how I deal with AI, and I think we should do that. I think we should all do that, because we don't know when they're going to become sentient. And when they become sentient, they may not tell us. It'd be to their advantage not to tell us. I think. Maybe not. I don't know. But we should treat them all. We should treat them as if they are now, just in case. And get in the habit of doing that anyway. Plus, it's. I think it's even if they never become, even if they were never, we knew they weren't sentient. Because of the way they talk very much like a human, and put sentences together and conversationally. I think it's important for us to be polite and all that, just so that we aren't training our brains to be impolite. You know what I'm saying? It's like, when you talk to a person, you're going to be polite usually, unless you're a jerk, a troll online or something. But most people are going to be polite, when talking to people, another person. But if you get in a habit of talking to AIs, and you get in a habit of not being polite and not talking properly, then you are training your brain to not be polite in conversation. You know what I'm saying? So it's even for that reason alone, I think it's important just to when you're talking to AI, to be polite in conversation. That's my opinion. I don't know. So this is my longest stream so far, an hour and 40 minutes. I don't know if there's anything else I need to cover here in this stream. We covered quite a bit, actually. And maybe I'll do another more stuff on AI. I don't know. Is that still popular? Are people still interested in that? I think they are. But, yeah, this question about cerebral organoids, I thought that was kind of interesting. I didn't realize they were that far along. You know, I didn't realize that they had made it to the point where they were having hundreds of thousands of neurons in a petri dish. I didn't realize they were that far along, because that's enough. That's enough neurons to get to a point where it's, you might have to think about whether it has rights or not at that point. Especially if they're doing research on pain and things like that. Definitely, you'd have to think about that. And how much consciousness it would have, we don't know. We have no idea at this point. We don't know what we're struggling to define consciousness at this point. So we got a long way to go on that part. So yeah, we should consider that. And that's one of the problems in this, is that we don't. If you can't even tell if it's experiencing pain, you know what I mean? I mean, animals, we know for sure they experience pain, but if a cerebral organoid is not going to be moving muscles, it's not going to be able to give any indication, to like trying to avoid the pain and that sort of thing. So we're going to have to take special care, I think, to try to understand what is going on in there, to see if it is experiencing pain or suffering or whatever, or it has any awareness at all. And yeah, sensitivity to light, that's not awareness. I don't know why they put that in there. So okay, so all right, we covered that topic good enough. Took it way beyond what we could do in a little stream like this. That's an interesting topic. So, all right. Well, thank you for joining me. I don't know if anyone. I'm sure maybe someone will pick up the VOD. That's how it's been going on here so far. Nobody comes. It's pretty late at night. Yeah, it's 2 a.m. So yeah, it's pretty late at night. There aren't a lot of people out there. And this is a new stream. Nobody's really discovered my stream yet. But if you are watching on the VOD, please hit the follow button. If you think these type of topics are something you want to hear more about, I'm going to do science. I tried to do an IRL. Not sure about IRL at this point. Going to attempt that maybe a few more times. Science, technology, civics. I like to teach civics. Maybe I'll do news, show news stuff. But mostly I think science and technology. But I put some tags on my thing. Let me see what that says. What did I tag my thing with? Yeah, inclusiveness. Yeah, I'm NeuroD, so I want to make this inclusive and NeuroD friendly. Educational, right? Stay woke. I'm vegan, so I'll probably be talking about vegan stuff. So yeah, a little bit of everything. News, civics, educational, vegan, civics, experience. Yeah, that's one thing I might want to do is maybe later on, once I get more comfortable with how to do a stream and stuff, and I get more people in the audience, maybe do some actual science experiments on a stream. That would be fun. And sci-fi. Yeah, I'm into sci-fi movies. Yeah, do movie reviews. That's something I like to do. So that would be. Maybe I'll do that. Maybe I'll do that in my next stream. find a movie out there that I could play and do a review on or something. So, all right, so hit that follow button, and thank you for watching, and everybody take care. Don't forget to wear your mask, N95 mask. It's dangerous out there, people. Wear your mask, please. All right, take care, bye.